Okay, so 7.6. Look at this cool thing. I made this all pink for you. Oh, 7.7. Right. Okay, so we're going to learn how to solve right triangles. And currently we've learned how to do the sine, the cosine, and the tangent, right? And we were using those trig functions to find sides of a triangle. What if the thing you want to try and find is the angle instead? Well, I'm glad you asked. That's what we covered in this lesson. So, let's get started. Those of you that are working on Cornell notes might want to write this down. Students will be able to find the angles of a right triangle given a pair of sides. Okay. How can you find the angles? Well, these are some warm-up problems. So, what I want you to do on your study guide, I want you to go ahead and do numbers 1 and 2 on this warm-up. And just do it on the back somewhere where you have some space, okay? So I'm going to stop the video for now and pause it. Okay, so those were our warm-up problems. We reviewed the cosine and the tangent. That was good. All right, let's move on to this then. Here's the basic idea. Inverse trig functions. Anytime we want to find an angle, we have to use the inverse trig function. So I want to show you what these look like. They're on your keypad. And if you look on your calculator keypad, you're going to notice there's a button called cosine. And there's a button right there on your calculator, right? Right above it, you should see something written in green writing. I'm going to show you. It's in green writing. And it should look like cosine with a -1. This is what we call the inverse trig function. The inverse. Okay? Now, the inverses always give you an angle. So if you're asked to find an angle, you have to use an inverse trig one. So you'll notice also there's one above the sine. And there's one above the tangent as well. Okay? So you'll have a sine -1 like this. And a tangent -1. Those are all inverses. So you want to activate the calculator to use these buttons. Well, I'm glad you asked. Well, that gives you the button there. So you're going to hit the green button first, and you get that button. Now here's the thing. In order to get an angle, you have to tell the calculator which two sides are you using. You see, which two sides do you think you use with the cosine? If you're using this one, you have to use the adjacent side and the hypotenuse. Does that make sense? Remember, the CA stands for adjacent over hypotenuse. So here's what you have to do when you're using this button here. You're going to have cosine -1. You're going to hit that button. Then you're going to have a set of parentheses. What you need to do is divide those two numbers. The adjacent side, okay, you got to put that number into the calculator. And you have to tell the calculator which one's the hypotenuse. And then you're going to hit equals. And then that will allow you to find out what the angle is. Does that sort of make sense? Yeah. That's the basic procedure. On all three of these inverse trig functions, it will give you an angle. You have to use the correct sides though. Like for example, if we're trying to find out the measure of angle A, I can use the inverse sine. Like for example, this is 5 and this is 13. I could use the inverse sine because I know the opposite side and I know the hypotenuse. And that inverse sine would give me the measure of this angle in degrees. No, you have to put that in there. Okay, so let's try a couple problems here. You see, this is just telling you about the inverse functions here. That's probably confusing to some people, but let's move on because that's not too helpful yet. Okay, so the first thing you need to figure out, based on your information, why do I hear a bunch of side conversations? I'm hearing things. Okay, so the first thing you need to decide is which trig function to use, which inverse one. We're trying to figure out the measure of angle A, okay? According to angle A, what is this side over here? That's the opposite side. According to measure of angle A, what is this side over here? That's the adjacent side. Based on the fact that I have the opposite side and the adjacent side, which inverse trig function should I use? The tangent. So here's what you want to do. Please, everybody, try this with your calculator. Use the tangent inverse button, that one. Then you'll have a set of parentheses. You need to tell the calculator this ratio. So you need to do 15 divided by 20 and then hit equals. This portion needs to be in parentheses. Okay? And everybody should get an angle in there. So I'll try it also. Okay, so it looks like to me we should get 36.869. And so now the nearest tenth is going to bump that up to a 9. So 36.9. Now, did anyone not get this answer? Okay. So let me just mention something on your calculators. When you take more advanced trigonometry, please pay attention so you get this. There is more than one type of angle measure. We will always be using degrees, and so your calculator has to be set to degrees. But there are other modes of angle measure, other types of angle measure. We have degrees, we have radians, okay, and we have actually what are called gradients. These are almost always included on a calculator, and almost always your calculator has this as the default. Okay, so if you didn't get the answer that I was talking about earlier, then you might want to check your calculator and make sure it's set on degrees. Okay, now you probably understand your calculator a little bit better. There's a degree, radian, and gradient. Radians are used quite a bit in trigonometry, and gradients are used in the military, as far as I know. Okay, so these are different ways to measure angles. We're used to measuring in degrees. Like most people know what 360 degrees is. It's a full circle, right? Well, that's the angle measures that we're used to. It's also the angle measures on a protractor. Okay, so anyhow, what we just found out is this. We found out that this angle is 36.9. Now, by the way, and once I have that information, how can I find out angle C? Yeah, these two angles are complementary, right? So you could easily find the last angle in here if you wanted. You're going to take 90 and you're going to subtract 36.9. And what do we get? 53.1. You see, so here's 53.1. Let me put the little degree symbol on top. Any questions? So once you find one of these angles, you can get the other one easily by subtracting from 90. Okay, let's continue. Here's a new triangle. What we're after is angle Q. And so, see if you can use your calculator and use... Okay, the first thing you want to do is make sure you use the correct trig function. Don't say it out loud. Figure out the trig function you should use, the inverse trig function, and then find out what the measure of angle Q is. I'm going to give you about a minute to figure this out, okay? I'm going to pause my video. Okay, so hopefully you got the same answer I got. We do the tangent. Because according to angle Q, this is the opposite side. This is the adjacent side. And remember me my little phrase there, so ka toa. You'll remember that the tangent uses the opposite side and the adjacent side. Those are the two sides I have. So now I just need to put those in my calculator. Always do this part in parentheses, okay? Create a little fraction there. Put 12 on top, the 8 down here. And I think we get, what did you say, 58? 58.3. Is it 58 or 56? Oh, hold up. 56.3. Okay, so once again, how do I get R now? Subtract it from 90, right? Alright, can we stop the scene? I know we got talent in here, but... Okay, so we could subtract from 90 to get this other angle, and I think it's what, 33.7? Well, you have to be able to add those two angles to get 90, right? So if you add 33.7, that gives me 0. I carry the 1 there. That gives me 9 plus 1, which is a 0. Carry the 1 again, I get 90 degrees. These two have to add up to 90, right? So isn't that 33.7 then? Okay. All right. Here's another problem. This comes up when you're building stages and comes up with building codes. Sometimes you have to have a ramp. And it looks like here, suppose your school building is building a raked stage. The stage will be 30 feet long from the front to the back with a rise of 2 feet. A rake angle of elevation of 5 degrees or less is generally preferred for safety and comfort of the actors. If it gets too steep, it's too easy to stumble. This is the same sort of problem with some inclines at restaurants and things like that. The wheelchair has to be able to get up this thing. If it's too steep, it's too hard. And if it's too flat, then they have to ride on the wheelchair for a long time. So these sorts of situations come up in buildings all the time, building codes. Well, so the question is, we want to be able to figure out this angle right down there. Well, based on that angle, this side over here is the opposite side. And this side here would be the hypotenuse. So I agree with Nayeli. We would use the inverse sign this time. And we want to put 2 over 30. And again, always put this part in parentheses. Why are we texting again? Oh, are you doing a calculator? I saw you a moment ago. All right. All right. Go ahead and tell me what you get. 3.8 what? 2. All right. Good enough, right? So according to this information here, is that stage okay then? Is that going to follow within their guidelines? Yeah, it's got to be 5 degrees or less, right? That's less than 5. It's bigger than 0. So the rake angle is fine. So now we proceed to build this. Make sense? Can you guys see where you do this actually in real life besides this? Where? Oh, I'll tell you one. Look, when when you guys are driving your cars and you're going to go around a curve like this, you know, the road often has an embankment. Okay, so that way you stay on the road, right? There's like this embankment. Like any of you guys see a racetrack, they have this curved up, right? They have this curve so that you stay on the road at certain speeds, right? Otherwise, you go off the road too easy, right? Uh-huh. So there you have a certain angle that comes up there for safety as well. Like when you're driving down like an on-ramp to a freeway, or you have a big curve or a sharp curve, there's an embankment. You see, here's the road. You're going down the road like this, right? But as you go down the road, there's this dash line in the middle, right? Your car, you want it to stay on the road, right? Well, sometimes we make an embankment at a certain angle so that the car stays on the road, so it's like tilted. Does that make sense? Okay, so that embankment has to be a certain angle degree, right? So it comes up in engineering all the time. Does this sort of make sense? Also, like when you build a house, you have a house, you have the roof up here, right? Well, you want the snow to come off your house, right? Same thing. So there's certain angles that we have to do so that way the snow will come off. On the other hand, you don't want the roof to be too steep because then the people trying to build it fall off. Does that make sense? So it makes it really challenging. So we have to put in these stakes to keep the guys from falling off. So there's certain guidelines all the time. Good applications of this stuff, right? All right, I've talked enough about applications. So anyhow, whoa. I think that's all we need to do. And so what we will do today is work on the study guide. You have about 15 minutes left to work on the study guide.